Hello, I'm going to present my project about the integration of image object detection with LLMs in Langflow. So the background of this project was that I asked ChatGPT to detect all people in an image and mark them in green and label them. And it said, here is an image. I could do it. So this was the image that I sent originally. I downloaded the image from ChatGPT and it looked like this. So, in conclusion, although the model could comment in a relevant way on the content of the image, it could not correctly mark its components. So, therefore, I wanted to develop a Langflow custom component that integrates an LLM chatbot with an object detection model. So first work package was to determine a suitable object detection model. And then I set out to write a Python script in a custom component that loads a JPEG image, sends this image to an object detection model, then receives the output from the model and applies it to modify the image and saves the resulting image to the drive. And also I need to modify the prompt to ensure that the chatbot takes into account that the image has been processed. So I was working with this object detection model that is available on Hugging Face, which is very powerful. It can detect buses and cars and dogs and persons and whatnot through a simple API call with the image. And you get back the box coordinates of the object, the label, and the detection score. So very nice. And now here is a practical demonstration. This is the Langflow canvas. So now Langflow is running locally on my computer. As you can see, it's quite a standard flow. Here's the chat input. Here's a system prompt, which defines how the chatbot is supposed to behave. As you can see, the chatbot is powered by an OpenAI LLM. Here I'm using 4.0 Mini, but you can change that, of course, if you prefer. Here one needs to define the OpenAI API key. And so let's look more into detail at the more interesting part in this flow, which is the custom component that enables the image object detection. So here I am using a call to a Hugging Face model. So therefore it needs a Hugging Face API key, of course. I am also defining the cache directory so that I can access directly to images that are uploaded in the chat input. And I also determine a save directory where I want the chatbot to save the processed images. Now let's look at the code inside. So the way I implemented this, well, there are, of course, in the beginning, a few libraries I'm importing, and then I defined a few different functions to facilitate the reading of images, the API call, and also then to extract the box coordinates so just the coordinates where detected objects are located. And then I have defined a function which draws out those detected objects with a little text label. So this is the most important function in a sense. You can see that there is a score cutoff here. That's important because if the detection score is lower than 0.8, then the object will not be drawn out in this case. But that can, of course, be modified according to your preference. So what I'm doing is I'm generating an overlay which is green, semi-transparent, in order to mark out the detected objects. And so this is repeated for every detected object, basically. And we generate the text box in that image. And then at the end, we use something called alpha composite to combine the original image with the overlay. And then we return the result. Then we come here to the actual class custom component. Now here I found it useful to understand a little bit better the anatomy of Langflow component. So here you have first the inputs, the outputs, and then in the output you also typically define a method that is going to determine the output coming out from the component. And that method is defined here. Now I added, of course, so here you can see that in the inputs we have the message coming from the chat input. You have the API key that needs to be defined, the cache directory, and the save directory. And those are strings. The API key is a secret string, and the input is a special Langflow type of structure called a message, and that can contain image files as well as text. Now, so here is the build method. So very simple, just going through those. Well, we define the API URL. You can find that on the Hugging Face website together with the API key. And I also put here the path to the image. So you have the cache directory, and then inside the message under files, you will also have the name of the file. So just by combining those, we get the right path. Then we read it out and make the API call, get the box coordinate, the object label, and the score. And then we feed those parameters into the modify image function and save the result. And last but not least important, we add to the message text part that that the image was received, it was processed using this very model, and that this modified image has been saved into the specified folder. So like that, the chatbot will respond in a coherent way. Okay, let's try this in action. We go to the playground. Okay, so here we have the chat input. Now let's put in the image we want to process in the, you can ignore this error message, and then we can type in another message. Tell me about Gen AI, just to give some more challenges to the chatbot. And so you can see it takes a little while for the custom component to run. The chatbot answers the question about Gen AI and then gives us an answer that it has processed the image using the specified ResNet 50 model, and then that it confirms that it has provided the modified image in the specified folder. So let's have a look at that. This is the result of the run. So we could identify cars, people, trucks, buses successfully. So this works. There is sometimes confusion between truck and bus, but we can even identify backpacks and handbags. So lastly, I'd like to mention a few words as an outlook of what can be developed in this custom component in the future. I think in the short term, it would be great to put the downloadable image in the chat output instead of putting it in the specified folder. I think there is also a need for a continuous RAM cleanup or cache cleanup, because I noticed that the program runs slower and slower after several runs. On the more intermediate term, I think there are more interesting things that can be done. I ran, for example, this image here, and I noticed that this cat was identified as a dog. So it would be great to be able to select a different model and to compare, and to implement a logging of the data on execution time and on the satisfaction of the calls in a database. Because then we can use this database to provide through RAG a model suggestion feature. And that could be a lot more powerful, because then maybe this can become a chatbot that can suggest for you the best suited object detection model for your computational resources and for the accuracy that you need. That could be a really nice future development. And that's the end of my tutorial. Thank you so much for watching. And if you have any questions, don't hesitate to write me, and let's connect. Wishing you a nice day. Bye.